Foundation for AI navigation. Technical structure forms the bedrock of successful GEO implementation. Without a robust technical foundation, even the most compelling content may remain undiscovered by AI systems. This lesson focuses on the crucial architectural decisions that enhance AI accessibility and processing efficiency. Optimizing your website's technical elements ensures that AI crawlers can efficiently navigate, understand, and index your content. This foundational work is critical for improving your content's visibility and its potential for citation within AI-powered search results and language models. Understanding AI crawler behavior. AI search engines deploy specialized crawlers, often referred to as bots or spiders, to systematically discover and index web content. These crawlers are programmed to follow links, read page content, and understand the relationships between different parts of a website. Each major AI platform utilizes its own distinct crawler with specific user agents and operational characteristics. Understanding the behavior of these crawlers is paramount for effective GEO. Different crawlers have varying crawl frequencies and purposes, ranging from training language models to powering real-time search features. Crucially, all legitimate AI crawlers respect standard directives like Robots.txt and Meta-Robots.txt, which allows webmasters to control their access. Robots.txt configuration for AI. The Robots.txt file serves as a critical instruction manual for web crawlers, dictating which parts of your website they are permitted or forbidden to access. For AI crawlers, this file is particularly important as it controls whether your content can be used for training data or real-time search results. Proper configuration ensures that public content is accessible while sensitive areas remain protected. A key consideration for GEO is to avoid inadvertently blocking legitimate AI crawlers from your public content. Blocking these bots prevents your website from contributing to their training data and appearing in AI-powered search overviews. Therefore, a strategic approach to Robots.txt is essential to maximize your content's visibility and influence within the AI ecosystem. Recommended Robots.txt directives. For optimal GEO, it is generally recommended to allow all legitimate AI crawlers access to your public content. This includes specific user agents like GPTBot, QuantBot, PerplexityBot, Googlebot, and Google Extended. Explicitly defining these allowances ensures that your content can be fully processed and utilized by various AI platforms for training and search functionalities. Conversely, it is crucial to block problematic bots and restrict access to sensitive areas of your website. Directories such as admin, shop private, cart, checkout, and account should be disallowed for all crawlers using a user agent star directive. This protects user data and prevents irrelevant pages from being indexed, maintaining the integrity of your site's public presence. Robots.txt, principles and testing. Adhering to key principles ensures your Robots.txt file effectively serves its purpose. First, always default to allowing AI crawlers for public content to maximize visibility. Second, block only truly sensitive or irrelevant areas to prevent data exposure and maintain crawl efficiency. Third, explicitly allow important content directories, especially if you've used broad disallow rules to guide crawlers effectively. Finally, always include your sitemap location within the Robots.txt file to facilitate efficient content discovery by crawlers. After implementing changes, it is crucial to test your Robots.txt configuration. Tools like Google Search Console's robots testing tool or other online validators can verify that specific crawlers can access or are blocked from intended URLs, preventing unintended indexing issues. Site architecture for crawl efficiency. The way your website is structured significantly influences how efficiently AI crawlers can discover, process, and understand your content. An optimal site architecture facilitates a smooth journey for bots, ensuring that valuable information is not buried deep within the site. This directly impacts how quickly and thoroughly your content is indexed and considered by AI systems. Don't. Prioritizing crawl efficiency in your site architecture means designing a logical and intuitive hierarchy. This involves minimizing the number of clicks required to reach important content and creating clear pathways for crawlers. A well-structured site not only benefits AI bots but also enhances user experience, leading to better engagement signals that further aid GEO efforts. Shallow site structure importance. A shallow site structure characterized by minimizing click depth is crucial for maximizing crawl efficiency. Content that is only 2 or 3 clicks away from the homepage is discovered much faster by AI crawlers. This direct accessibility ensures that important pages are prioritized and indexed promptly, preventing valuable content from being overlooked. This architectural approach also enhances the flow of link equity throughout your site. When content is easily reachable, internal links pass authority more directly, signaling the importance of those pages to AI. A shallow structure improves both crawler discovery and the perceived priority of your content, making it a fundamental principle for effective GEO. Clear URL structure best practices. A clear and descriptive URL structure is vital for both human users and AI crawlers to understand the content of a page before even visiting it. Good URLs are readable, include relevant keywords, and reflect the site's hierarchy. This transparency helps AI categorize your content accurately and improves its chances of being cited in relevant queries. Consistency in URL patterns across similar content types is also essential, creating a predictable organization that crawlers can easily follow. URLs should be short but meaningful, ideally 3 to 5 words, using hyphens as word separators instead of underscores. Furthermore, always use lowercase letters to prevent potential case sensitivity issues and maintain uniformity across your site. Breadcrumb navigation for hierarchy. Breadcrumb navigation is a secondary navigation scheme that reveals the user's location within a website's hierarchy. For AI crawlers, breadcrumbs are incredibly valuable as they explicitly show the content hierarchy and the relationships between parent and child pages. This structured information helps AI build a more accurate understanding of your site's organization and topic clusters. Implementing breadcrumbs with schema.org's breadcrumb list markup provides structured data directly to AI engines. This not only improves navigation clarity for users, but also signals content relationships in a machine-readable format. The explicit positional information within the schema helps AI understand the exact path from the home page to the current page, reinforcing the site's logical structure. Navigation and internal linking strategy. A well-thought-out internal linking strategy is fundamental for guiding AI crawlers through your content ecosystem and signaling the relationships between different topics. Internal links help distribute link equity or authority across your site, ensuring that important pages receive the necessary signals to rank well. This strategic approach helps AI understand the depth and breadth of your expertise. Effective internal linking goes beyond simply connecting pages. It involves creating a logical network that reinforces your site's thematic coherence. By carefully crafting internal links, you can help AI connect related pieces of content, build a comprehensive understanding of your subject matter, and ultimately improve the visibility and authority of your entire website. Hub and spoke model for linking. The hub and spoke model is an effective internal linking strategy where a central pillar page or topic hub links to several related, more specific content pieces known as spokes. This structure clearly signals to AI crawlers that the hub page is the authoritative source for a broad topic, while the spokes provide in-depth coverage of subtopics. Topics. This model helps establish strong topical authority. In this model, each spoke page should also link back to the central hub and to other highly relevant spoke pages. This bidirectional linking reinforces the thematic connection and distributes link equity effectively across the cluster. The hub and spoke approach creates a comprehensive content ecosystem that is easy for AI to understand, improving discovery and ranking for a wide range of related queries. Contextual internal linking best practices. Contextual internal linking involves embedding links within the body of your content using descriptive anchor text that accurately reflects the topic of the linked page. This practice is far more effective than generic click here links, as it provides AI crawlers with clear signals about the relevance and content of the destination page. Natural keyword-rich anchor text helps AI understand semantic relationships. Effective anchor text should be descriptive, naturally integrated into the surrounding sentence, and varied to avoid over-optimization. It should also be highly relevant to the keywords and topic of the page it points to. By using contextual links, you enhance the user experience by providing relevant resources and simultaneously strengthen your Go signals by clearly defining content relationships for AI, related content, and link density beyond in-content links. Providing related content recommendations at the end of articles is an excellent way to keep users engaged and guide AI crawlers to further relevant pages. These sections, often labeled related guides or further reading, reinforce topical connections and encourage deeper exploration of your site's content. This practice helps AI discover more of your valuable content. Regarding internal linking density, a balanced approach is crucial. For shorter articles, 500 to 1,000 words, 3 to 5 internal links are generally sufficient. Medium articles, 1,000 to 2,500 words, can accommodate 5 to 10 links, while longer pieces, 2,500 plus words, may benefit from 10 to 20 links. The key is to ensure each link adds value and is not merely for density, avoiding overwhelming the content or diluting its focus. XML sitemap optimization essentials. XML sitemaps are essential files that list all the important URLs on your website, providing a roadmap for AI crawlers to discover and prioritize your content. They act as a direct communication channel, informing search engines about pages they might not otherwise find through standard crawling. A well-optimized sitemap ensures comprehensive indexing. Each entry in your sitemap should include specific elements to provide maximum information to crawlers. The tag specifies the URL, indicates the last modification date, suggests how often the page is likely to change, and hints at the relative importance of the URL compared to others on your site. These elements help AI understand the freshness and significance of your content. Sitemap best practices and submission. To maximize the effectiveness of your sitemap, ensure the dates are updated accurately whenever content changes. This signals freshness to crawlers, encouraging re-indexing. Set appropriate values, daily for news, weekly for blogs, monthly for evergreen content, and yearly for static pages. This helps crawlers allocate their resources efficiently. Utilize these tags strategically. Assign 1.0 to your homepage and critical pillar content, 0.8 to 0.9 for important categories and top guides, and lower values for less critical pages. After creation, submit your sitemaps to major search engines like Google Search Console and Bing Webmaster Tools. Crucially, reference your sitemap location in your Robots.txt file, providing an additional discovery path for crawlers. Organizing large sitemaps and limits. For very large websites exceeding sitemap limits, it's best practice to use a sitemap index file. This master file lists multiple individual sitemaps, allowing you to organize your URLs by content type, e.g., sitemapblog.xml, sitemapresources.xml. This modular approach keeps sitemaps manageable and ensures all content is discoverable, even on extensive sites. Sitemaps have specific technical limits, a maximum of 50,000 URLs per sitemap file and a maximum file size of 50 megabytes uncompressed. If your site surpasses these thresholds, you must split your sitemap into multiple files and then reference them all within a sitemap index. This organized structure helps AI crawlers process your site efficiently without encountering file size or URL count limitations. Canonical URLs and content consolidation. Canonical URLs are a critical technical element for preventing duplicate content issues, which can confuse AI crawlers and dilute your content's authority. Duplicate content arises when the same or very similar content is accessible via multiple URLs, such as variations with or without a trailing slash, different parameters, or HTTP or HTTPS versions. This can lead to crawlers wasting resources and splitting ranking signals. The solution lies in implementing canonical tags, which explicitly tell AI crawlers which version of a page is the preferred primary URL. By adding a canonical tag in the section of your HTML, you consolidate all signals, like link equity and citation potential, to a single authoritative version. This ensures AI focuses its attention and attributes value correctly, strengthening your GEO efforts. Canonical tag best practices. Implementing canonical tags effectively requires adherence to several best practices. Firstly, every page on your website should ideally have a canonical tag, even if it's self-referencing and points to itself. This proactive measure prevents unexpected duplicate content issues from arising. Secondly, always use absolute URLs in your canonical tags, e.g., https, yoursite.com, or never relative ones, to ensure unambiguous direction for crawlers. Thirdly, maintain consistency with HTTPS and www versions. Choose one preferred version, e.g., https://yoursite.com, and ensure all canonical tags point to it, avoiding mixed signals. Similarly, be consistent with trailing slashes. Pick one convention, e.g., https://yoursite.com page or https://yoursite.com page, and apply it uniformly across your site. These consistencies are crucial for clear communication with AI crawlers and consolidating ranking signals. Common canonical use cases. Canonical tags are particularly useful in several common scenarios to manage duplicate or near-duplicate content effectively. For paginated content such as blog categories or search results, the canonical tag on subsequent pages, e.g., page 2, page 3, should often point back to the main category or first page. This consolidates authority to the primary entry point while allowing crawlers to access all content. Another common use case is for print versions of articles or content. If you offer a printer-friendly version of a page, its canonical tag should point to the original full web version. Similarly, for regional variations of content, for example, example.com US shark product and example.com UK product, if the content is identical, the canonical tag can point to the main preferred version. This ensures that AI understands the primary source and avoids splitting signals across identical content. Site speed and performance for AI website. Speed and performance are no longer just about user experience. They are critical factors for how efficiently AI crawlers interact with your site. Fast-loading sites are crawled more frequently and thoroughly, ensuring that your content is discovered and indexed promptly. Conversely, slow sites can lead to reduced crawl budget, meaning important content might be overlooked or indexed less often. Performance directly impacts AI's ability to process your content completely. Timeout issues on slow pages can prevent crawlers from accessing full content, especially if it relies on JavaScript rendering. Furthermore, site speed contributes to user experience signals, which AI systems increasingly use to assess content quality and authority. A fast site signals a well-maintained high-quality resource. Critical performance metrics. Several critical performance metrics directly influence how AI crawlers perceive and interact with your website. Time to first byte, TTFB, ideally under 600 milliseconds, measures the responsiveness of your server. Optimizing server response, caching, and using a CDN are key to improving TTFB. A low TTFB ensures crawlers receive the initial data quickly, preventing early timeouts. Largest contentful paint, LCP, aiming for under 2.5 seconds, measures when the main content of a page becomes visible. First input delay, FID, targeting under 100 milliseconds, quantifies the time until the page becomes interactive. Cumulative layout shift, CLS, ideally under 0.1, assesses visual stability during loading. Optimizing images, minimizing JavaScript, and ensuring stable layouts are crucial for these metrics, directly impacting both user and crawler experience. Performance optimization checklist. A comprehensive performance optimization checklist covers various aspects of your website. For images, ensure they are compressed, WEBP or AVIF, properly sized, lazy loaded for off-screen content, responsive, and include width-height attributes. These optimizations reduce file sizes and improve loading times, which are crucial for AI crawlers. For CSS and JavaScript, minify and compress files to reduce their size. Inline critical CSS and defer non-critical CSS and JavaScript to prioritize essential content rendering. Ensure unused CSS is removed. On the hosting front, utilize a fast server, implement a CDN for static assets, configure browser caching, and enable gzip compression. These server-side optimizations significantly boost overall site speed, benefiting both users and AI crawlers. Testing performance and budgets. Regularly testing your website's performance is crucial for maintaining optimal speed. Utilize tools like Google Page Speed Insights for overall scores and recommendations, GT metrics for detailed analysis, and web page test for advanced testing from multiple geographic locations. Chrome DevTools offers real-time performance monitoring directly within your browser, providing immediate feedback on changes. Implementing a performance budget helps set clear limits and monitor key metrics. Aim for a total page size under 1 megabyte, JavaScript under 300 kilobytes, images under 500 kilobytes, and CSS under 100 kilobytes. Strive for a total load time under 3 seconds. These budgets ensure your site remains lightweight and fast, directly impacting crawl efficiency and user experience, which are vital for GEO's success. Mobile optimization for AI access. Mobile optimization is no longer optional. It is a fundamental requirement for effective GEO. AI crawlers, particularly Google's, increasingly prioritize the mobile version of your content for indexing and ranking decisions. This mobile-first indexing means that if your mobile site is not optimized, your content's visibility in AI search results will be significantly hampered, regardless of your desktop site's quality. Ensuring your website is fully mobile optimized guarantees that AI systems can access, crawl, and understand your content efficiently on any device. This includes responsive design, touch-friendly elements, readable text without zooming, and the absence of horizontal scrolling. A seamless mobile experience directly translates to better crawlability and higher perceived quality by AI, leading to improved GEO performance. Mobile optimization details and testing. Key aspects of mobile optimization include implementing responsive design using the viewport meta tag and media queries, ensuring content adapts seamlessly to various screen sizes. All interactive elements, such as buttons and links, must be touch-friendly with a minimum target size of 48 by 48 pixels and adequate spacing. Text should be readable without requiring users to zoom, typically with a base font size of 16 pixels and appropriate line height. Crucially, your mobile site must avoid horizontal scrolling, which indicates content overflowing its container. Images, videos, and iframes should have max width 100% and height auto to prevent overflow. To test mobile optimization, use Google's mobile-friendly test for quick checks, Chrome DevTools device mode for responsive behavior simulation, and always perform real device testing across different screen sizes to verify touch interactions and overall user experience. These steps ensure comprehensive mobile readiness for AI. Case study: technical structure success. A SaaS documentation site faced low AI citation despite high-quality content, primarily due to poor technical implementation. Initial audit revealed critical crawl accessibility issues. GPT bot was unintentionally blocked in Robots.txt. No sitemap was submitted, and average load times were a slow 4.5 seconds. These issues prevented AI crawlers from efficiently discovering and processing their valuable content. Structural problems further compounded the challenge with content buried 5 to 6 clicks deep, inconsistent URL patterns, and minimal internal linking. Mobile optimization was also lacking, resulting in a non-responsive site with small text and horizontal scrolling. These combined technical deficiencies created significant barriers for AI access and understanding, severely limiting the site's GEO potential.